So in this video, we're going to do the sum, difference, product, and quotient of functions. So we're combining functions together. So the first is the sum. So the definition of f plus g of x is defined to be f of x plus g of x. All right? The difference is f minus g of x is defined to be f of x minus g of x. Okay. The product is defined to be f times g of x, which is f of x multiplied by g of x. And then the quotient is f divided by g of x equals f of x divided by g of x as long as g of x does not equal 0. Okay, still can't divide by 0. All right, so to show you how simple these rules are, let's take some functions here. So let's define f of x to be x plus 2, and let's define g of x to be x. Now say that I want to find f plus g of x. What do I do here? I literally take the definition, that's f of x plus g of x. Okay, so what does that equal? Everywhere I see an f of x, I'm going to replace it with x plus 2. And everywhere I see a g of x, I'm going to replace it with x. So this becomes what? This becomes x plus 2 and then plus x. And can I combine anything? Yes, I have 2x plus 2. Okay? Now say I wanted to calculate f plus g of 3. Well, what do I do here? I plug in everywhere I see an x, I'm going to plug in a 3. So this becomes 2 times 3 plus 2, which is 6 plus 2, which equals 8. Okay? Let's take the same two functions and let's do f minus g of x. This is f of x minus parentheses g of x. So this is equal to x plus 2 minus x. So that's x plus 2 minus x, which is equal to just 2. Now say I was going to calculate f minus g of 3 again. When I plug 3 in, well, what is the only thing that's here? It's equal, it's a function that's a constant. No matter what x I plug in, I always get 2. So my answer here is just 2. Okay? Let's try multiplication. fg of x. How do we do this? This is equal to parentheses f of x times g of x. And so what is f of x? It's x plus 2. And what's g of x? It's x. So if I multiply this out, I distribute. So x times x is x squared, and x times 2 is 2x. So if I was going to calculate fg of 3, what would that be? That would be 3 squared plus 2 times 3. So 3 squared is 9 plus 6 gets me 15. And last, I've got f divided by g of x. So this is going to be f of x divided by g of x. F of x is x plus 2, and then divided by x. So does this simplify any? I mean, you could simplify if you wanted to. You could make this into x divided by x plus 2 divided by x, which equals 1 plus 2 divided by x, if that's really what you wanted to. Or you could just leave it as x plus 2 over x. Either one of those answers would be fine with me, okay? Now, if I wanted to find f of g of 3, I plug in, I have 3 plus 2 divided by 3, so that's 5 over 3. All right? So the domain for the new function is the intersection of the domains of the two functions that compose it. All right? So just to give you like a graphical idea of how this works, all right? So you're combining two functions together, right? And say that the domain of f is from -1, so like from -1 to positive infinity, okay? And then your domain for g is from negative infinity up to, but not including 5. Then the domain of f and g, right? So the combining of the two f and g functions, so this is my g here, the domain of those would go from this -1 up to this 5 here. It would be where these two overlapped, and they overlap only in these areas right here. This is where they overlap, okay? So it's the intersection of the two functions that make up the f and the g. Now the good thing about x plus 2 and x is the domain for both of those are all real numbers. So both of them are from negative infinity to positive infinity, and negative infinity to positive infinity. So their intersection is still all real numbers, okay? The problem comes into play whenever I end up dividing, and remember we had that restriction, thou shalt not divide by 0, right? So where would this piece be equal to 0? It'd be whenever x is equal to 0. So that would have to get thrown out of my domain. Okay, so the domain for that function would be all real numbers except for 0. Okay? Now, let's try a little bit more complicated composition, and I think you will find that the rules are the same, it's just the algebra gets a little more challenging. So let's do f of x equals the square root of x plus 2, and g of x equals x squared minus 1. Okay? So the first thing I want to do is I want to get the domain of each. Now with square roots, I can't take the square root of a negative. That's the one rule, right? So the only way this is negative is if x plus 2 is less than 0, right? So I need this to be greater than or equal to 0, and I'm okay. So if I solve this for x, then as long as x is greater than or equal to -2, meaning, you know, if you're on a number line, then from -2 onward this way, we're good to go. So bracket -2 to infinity is my domain, okay? What about over here for g of x? Well, this is a squared, and it's a parabola that's shifted down 1. And it turns out parabola, that's a nice polynomial. It's smooth and continuous for all real numbers. So the domain goes from -infinity to positive infinity. So my domain is good there. So really the only thing we got to watch out for is our square root one, okay? So let's try to figure out the new function and then look at its domain. So f plus g of x. So f plus g of x is f of x plus g of x. So what is this equal to? This is the square root of x plus 2, and then plus x squared minus 1. Now, I can't combine this piece with that piece, and neither one of those are constant, so I can't combine anything with that negative 1. So that's as simplified as you can get it. Now, the question is, what about the domain of f plus g, right? So what is the domain of f plus g? Well, the domain is the intersection of the two. So if this is my number line here, and I know that my domain for g is all real numbers, but the domain for f is only from -2 to infinity, okay? Then what is the intersection of the two? Well, that is from -2 to infinity. So -2 to infinity is where they overlap. All right, let's try to do f plus g of 2. Evaluate that. Well, that would be the square root of 2 plus 2 plus 2 squared minus 1. So what's that equal to? That's equal to square root of 4 plus 4 minus 1. Square root of 4 is 2. So 2 plus 4 is 6. Minus 1 gets me 5. So my answer there, evaluated at 2, it's equal to 5. So if I plug in that 2 over here, it outputs a 5 up there. All right? Now, let's do, instead of addition, let's do let's do f divided by g first. Okay, f divided by g. So if I do f divided by g, that's f of x divided by g of x, as long as g of x is not equal to 0. So f of x is the square root of x plus 2, and g of x is x squared minus 1. Now, what are my restrictions? The denominator can't be equal to 0. Okay, so I set it to be equal to 0 to find the bad values. Now, how do I do this? I'm going to add 1 to both sides. I get x squared equals 1. If I square root, I get a plus or minus. Square root of 1 is 1, so it's plus or minus 1. So bad values are plus or minus 1. All right? So for sure, so on our number line, if 0's in the middle, I can't have a -1 and I can't have a +1. Those are out of the picture. So right now, everything but those. Okay, so I skip over those values. All right. So I'm skipping over those values. Now, what else is bad? Well, I can't take the square root of a negative. So when I see that square root of x plus 2, okay, I have that inside greater than or equal to 0. So x has got to be greater than or equal to -2. So at -2, I know that I got to be greater than or equal to it this way. So that messes up everything over here. So really what it is it goes from -2 to -1, and it skips over -1 and goes to 1 and skips over 1, and then it goes out to infinity. So how do I write that in the domain? Because this is probably the most complicated part of it. The domain of f divided by g, that is from -2 to -1, parentheses, and then I skip over -1, and I go to 1, and I skip over 1, and I go out to infinity, just like that. So that's about as complicated as it gets, okay? Let's try one more. And if you can do this one, you got it all down. Okay, so g divided by f. G divided by f. Whoo! All right, so that's g of x divided by f of x. Now, getting the function is not too bad. All right, g of x is just x squared minus 1. F of x is just the square root of x plus 2. Okay? The domain can be a little tricky. Now, the good thing is, in the numerator, we've got no problems. Okay, this is all real numbers, -infinity to infinity. All right, so that anything works for squaring it. You can square any number. However, the denominator is the issue. okay? So the denominator, we can't have negatives in the square root, so x plus 2 greater than or equal to 0. So that gets me x greater than or equal to negative 2. No biggie. But what happens about x equal to negative 2? What happens if I plug a negative 2 in here? Well, what does that do? That gets me negative 2 squared on top minus 1, which is okay. But then it's divided by negative 2 plus 2. Well, negative 2 plus 2 is 0. Square root of 0 is 0. So I'm dividing now by 0. So that's bad. So what do I need to do? Not only do I need to account for this not taking a square root of a negative, I also have to account for this whole thing cannot be equal to 0. Remember the denominator, okay, whatever's in the denominator, that thing can't be equal to 0, okay? So that's the change up there and kind of the curveball, all right? So very tricky, but it is still doable. So what is it? Instead of having the bar underneath, it instead would get rid of the bar, and so it's just x is greater than negative 2 is the domain. So the domain goes from negative 2 to infinity. Okay? So that's the trick right there. All right.